Greetings to everyone. So in this class, we are going to discuss about the CAD Lab experiments. That is experiment number 2, the second part, analysis and design of continuous beam. So last class, we have discussed that the analysis and the design of fixed beam as experiment number 2.1. Okay. So for this, we are going to have the given data, that is the beam we are going to take. So the length of span AB is 5 meter and it has the UDL of throughout the length with the intensity of 15 kilonewton per meter. And the second span BC of 5 meter total length and it has the point load of 25 kilonewton intensity at a distance of 3 meter from support B. And the span CD has the length of 1 meter and it has the point load of 10 kilonewton at its free end. So this beam we have to do the analysis and the design. And now some data we are going to assume. First one is FCK, that is compressive strength of concrete, as 25 Newton per mm squared, and yield strength of steel as 4 on 5 Newton per mm squared, and breadth of the section we are going to assume as 0.25 meter, and the overall depth we are going to assume as 0.4 meter. And also clear cover D, we are going to take it as a, that is D dash, we are going to take it as a 40 mm. Okay, so this is about our given data. Now we have to do analysis and design of this continuous beam using STAAD Pro. So now I am going to share the STAAD Pro screen to you. So the first thing, we have to assign the job. Okay, so click on new project, space, file name as continuous beam, and the location is at experiment number 2, continuous beam, and click OK. And you have to ensure the length should be in meter and the force unit should be in kilonewton. Click on next. So add beam, finish, so that we can get the window screen like this. Now we have to make it for the front view, and in the given problem the total length is 11 meter. Okay, now but in the x-axis we are having only 10 meter. Okay, now we have to edit this data. So click on modeling, setup. So first assign the job name as analysis and design. And job number as 2.2, client name as engineer name as MH, and go to geometry. So here we are going to edit the geometry. Okay, now so in x-axis I'm going to give some 15 meter. Okay, click OK. So now by using grid selection, so first span is A to B is 5 meter, then 5 to 10 for span BC, next for span CD 10 to 11, and click escape. Okay, so click, if I'm going to click this icon, I can get different span, that is AB, BC and CD. Okay, so now I have to move for general. So click on general, click the property in order to assign the cross section. Okay, so click define. So here the cross section is rectangle, so click the rectangular section, and breadth of the section is 0.25 meter and the depth of section is 0.4 meter. So ZT is for breadth, YD is for depth. Okay, and the material is concrete. Click add, then close. So we have to assign this. Okay, so click on here, use assign to view. So entire the section, it has to maintain the uniform section. So assign to view as yes. So entire section it have been assigned. Now we have to go for support condition. Click here, support and create. So one fixed support, click add, then create another. So pinned support is also there. Click add. So support 2. So fixed support. So use cursor to assign. So support A is fixed support. So I'm going to give A here. Okay, now next. So support 3, that is pinned support. Okay, now or simply supported. So use cursor to assign. So support B and support C. These two are pinned support. So I have assigned the support. Next to load cases. Click on load and definition. So click load case details again. Add. Then go to loading type. Dead load. So DL. So dead load with respect to the cross-sectional details and the material used. The system is going to generate automatically for the entire span. Okay, add. Next, live load. So there are 3 live loads. One is for span AB, another one is for span BC, and another one is for span CD. Okay, so UDL with respect to span AB. So add. Next, point load 1 for span BC. Add. Next, point load 2 for span CD. Add, then close. Now I have to assign the values. So for dead load, it was there already -1. So no issues. Add and close, and I have to assign it. So this self weight is going to assign for entire the beam. Okay, so assign to view. Click assign to view, assign. Yes, so entire the section it is uniform. Okay, now next to UDL. So click on add. Okay, member load, uniform force. So load intensity is 15 kilonewton meter. So -15. So which is acting downward. Okay, now and D1, D2. So the load value is 0 meter to 5 meter. So here the load intensity, the load will start at 0 meter, that is span support A to support B. Okay, now so that's what. So D1 is 0 and D2 is 5 meter, so that the load is going to end. So click on add, close. Now I have to assign this. So click here, use cursor to assign. So click the span AB. So it is going to be here. Okay, close. Next, point load 1. So which is acting at span BC. Okay, now click add. Then click member load. Then give the load intensity as -25 kilonewton. Sorry, I have to click concentrated load. So give the intensity as -25. So D1 is from the left to support, it is 3 meter. Okay. So the D1 value I am going to keep 3 meter. That is from the support B, it is placed 3 meter distance away from support B. Okay, now so that's what 3 meter. So add close. So this load I am going to give. So I am going to assign. So click on that, assign, use cursor to assign, and click here. Okay, now so the load has been placed here also. So next, point load 2. Okay, now click on that load, add, then click member load, then click concentrated force, then the load intensity as 10 kilonewton. So minus 10, it is acting downward, and D1 distance. So from the support C, it is placed 1 meter away from that. Okay, so click, so enter 1 meter. Okay, add, close. So click here, assign, use cursor to assign, click here. So it's all about your load assigning. Okay, now we have to combine all these loads. Okay, so click load case details, add. So here define combination, then load cases 4, give load factor of safety as 1.5, and whatever the load we have assigned already, it is individually, it is available here. We have to give it right side so that we can click double arrow symbol, so that the value is going to, that is all the load is going to combine along with the factor of safety. Okay, add and close. Now here you are having one tab, so click here, see all the combination of loads. Okay, now so now you have to load values you have to see. So click loads and symbols icon, apply, okay. So load will come. Okay, so all the loads, and so all the load and its intensity you have, we got it here. Okay, okay, here we have. Okay, so now we have to run the analysis. Before run the analysis, we have to click analysis print and click all, add, then close. Okay, now after that, go to analysis, run analysis, save, so that we can get the report here. Okay, now view output file and click done. Okay, so that we can get the report like this. So we got the report like this. Excuse me. So here the number of joints are 4. Support A, support B, C, D. There are 4 joints. There are 3 members. Okay, now, and number of supports are 3. That is support at A, support at B, support at C. Okay, now then there are primary load cases. There are 4 load cases. One is dead load, another one is one UDL, another one point load, another one point load. So there are 4 load and one combined load. Okay, now. So this is what our analysis report. So in order to get the report in terms of figure, okay, now. In order to get the report in the form of diagrammatic representation, I have to click post processing icon. Okay, now, and click apply. Okay, so that I can get it. Okay, now I need shear force diagram, correct? So click FY icon here so that I can get the shear force diagram here. In order to get the shear force values, click results, view values, beam results, click shear end maximum at midpoint. Annotate, click close. Okay, now. So this is what I can get the diagram. Okay. So this is the fixed end. So shear upward shear force, then downward due to load, and again at support. and it is going to be a downward, and again at support it is going to increase. At the free end it becomes 0. Okay, now so this is about shear force diagram. Click take picture icon and save it as SFD and click OK. Next for bending moment, click MZ. Okay, and go to results, view value, beam results, and maximum midpoint. Annotate, close. Okay, now so this is our bending moment diagram. Okay, and take picture. So BMD, click OK. Then next, deflection diagram. So in order to get the deflection values, click results, view value, beam results, then maximum resultant. Close. So here the maximum deflection values are came. So with respect to span AB, it was 1.737. With respect to span BC, the maximum deflection value was 1.034. And with respect to the span CD, the maximum deflection at the free end was 0.312 meters, 3 mm, sorry. So in order to get the picture, take picture. So this is deflection diagram, DD, click OK. In order to get all these diagram in the report form, click reports, click on down arrow, pictures, select it, click OK. So we can get the report like this. Okay, continuous beam. This is our shear force diagram. In the next page, we are having bending moment and deflection diagram. Okay, so next we should move on to design part. So in order to do the design, click modeling, go to design, then concrete. Okay, so select the code IS456 for the design of concrete section. Select parameters, click OK. After doing that, go for define parameters and click depth. So here the effective depth you have, sorry, the clear cover you have taken as 0.040, that is 40 mm. Click add. Then FCK value is 25 Newton per mm squared. Then FY value as 415 Newton per mm squared. And FY secondary reinforcement also 415 Newton per mm squared. Then maximum main reinforcement as 25 mm. Maximum secondary reinforcement as 16 mm. Then minimum main reinforcement as 16 mm. Then minimum secondary reinforcement as 12 mm. Add, close. So if I'm going to see in the right space, there are question marks available. So I have to assign those values. Click here, assign to view. It is going to applicable for full length of the beam. So give assign to view and as yes, FC. Assign to view. Assign. Yes. FI main. Assign to view. Assign. Okay, after assigning all these values, I have to do the commands. Okay, and click the commands, design beam, add, then take off, then add in order to get the reports. Close. Okay, then design beam, click assign to view. Yes. Okay, so go to analysis bar print, click all, add, then close. Then go to analyze, run analysis, save, so that we can get the output data in the form of printout, PDF. So to view the output of design parameters, okay, now we can have here. So in that, click concrete design. So the reinforcement detailings are came in the form of written statement. Okay. So in order to get the reports in diagrammatic representation, that is detailing diagram. So I have to go for my start for beam screen. Okay. So do double click here so that I can get the sectional details for the span AB. Okay, now, and if I want sectional details for span BC, I can get it here, concrete design. Okay, so here the spacing and everything are going to change. And for span BC, CD, so I can have it here. So like that, I can get the entire design data or design detailing here. Thank you all.